My name is Caio Mucchiani. I am a PhD student in mechanical engineering here at the University of Pennsylvania. I work with Dr. Mark Kim at the GRASP lab. Today I'm going to show you guys how can we make robot manipulators more accessible. To make robots more affordable, there are two ways to approach this problem. The first one is simplifying the robot hardware, and the second one is simplifying what the robot does as a task. In this case, we want to simplify the robot hand. It's called the UR10 from Universal Robotics. It costs approximately $45,000. So as you can see, usually robotic mechanisms are kind of expensive. However, our idea here in our research group is to make robotics more accessible. In this case, what we're trying to do is to make the end effector or the robot hand more accessible. So when you look at conventional robot arms, right? The robot hand usually consists of a single motor or multiple motors, and they can cost up to tens or thousands of dollars, right? One of the greatest challenges nowadays in robotics is manipulation. So how can you grasp objects and interact with them, hand off objects to people? And the problem is we don't know how to do this in a unique way. We don't know if we might need just a single hand to do all types of interactions with objects, or we might need different hands or different robotic hands to do all different types of interactions with the object. So investigating, in a way, robot manipulation is trying to come up with an answer to that question. So when we look at babies and how they manipulate objects around them, let's say they're putting blocks on top of each other. They're not really concerned how they are picking the block and putting on top of each other. In robotics, we call that pick and place. This is one of the most well-known type of operations in industry. Let's say in the automotive industry, for instance, many cars use robots to pick parts from one point and place them somewhere else. In this case, what we are trying to do is to accomplish pick and place applications with a 3D printed fixed shape end effector, like this one. So we have one here in the robot arm, and we try to pick objects depending on the characteristics of the object, right? So specifically, this robot arm mimics kind of like our arm, although our arm has 7 degrees of freedom. In other ways, it can move in 7 different ways. This one has 6, which is able to achieve any point in space within its workspace. So as you can see, we have 1 degree of freedom from the base, a 2nd degree of freedom from the shoulder, a 3rd degree of freedom from the elbow, a 4th degree of freedom from the wrists, the 5th degree of freedom also from the wrists, and the last degree of freedom here, moving the end effector. So the advantage of making low-cost mechanisms is able to achieve the same type of tasks as you would achieve with a conventional one. And this is what we are trying to do in this study. If you look at any baby, right, manipulating objects or just picking objects around them, it seems so easy and so basic, and we take it for granted for sure. However, if you are just trying to pick up an object using a robot arm, it can be pretty tricky, and I think it's this thing of like how something so simple, but by the way, by a computer, right? So how something so simple can be so difficult for a robot. However, very complex calculations can be done very easily by a robot. So it's kind of interesting. I think just again, we figured that out in robotics a lot, but once again, figuring that out was kind of an interesting thing. Specifically in this one, we worked on the hand or the end effector and the theory behind being able to grasp the objects using the arm and the hand. What we do here is we use physics, right, or acceleration to maintain the object within the end effector without squeezing it, but still able to grasp it. I want this type of motion, right? I want this type of state, right? Safe against gravity. This is not safe, right? So if I apply some acceleration, right, I'm able to go from an initial state here to a goal state just by applying acceleration to the object. So that's kind of the idea. So I'm applying an acceleration to let the object stable within the end effector. What I also focus on my research is working on service robots, which is a definition for robots that can help in some sort of tasks. In that case, it's for older adults aged 65 years and older. They live in nursing homes, and they have some sort of limitation, be that grasping objects. So we want to make robots that facilitate any type of tasks. They might need a human for that. And so we want to make them more independent in a way. So that's why we're trying to investigate how can we have a robot help an older adult be more independent, yet freeing the human caregiver or the human healthcare worker to do what they do best, which is caring for the older adult.
Hi, Mrs. Jones. Stopped by to remind you to drink water, because staying hydrated will help you feel good. Would you like a bottle of water?
Yes.
Okay, please take a bottle.
Some consider a cell phone a robot. Back in the days, cell phones were extremely expensive. I'm pretty sure many of you guys watching wouldn't even remember, but cell phones were only accessible for the rich. Nowadays, you can buy a cell phone pretty cheap, and I'm pretty sure most of you might have. So that's the idea behind robotics being more accessible. Right now, it's like, it may be a higher cost, or for instance, the robot arm that I'm doing the demo costs around $45,000. However, the idea behind the research is making something that more accessible. I would encourage you to buy, or ask your parents to buy, toys that you can take it apart, they won't complain, you can play around, you can see how you can modify them, and then try to put them together back and see whatever you learned, if that makes sense or not. That's how I did, and I felt that gave me this, took the fear of dealing with stuff they were not familiar with. Like, let's say something broke down in your house. Let's say, oh, let me fix that. Let me just have a look. I think that was very essential, being able to understand how things work and be able to look them at a different perspective. And also buy Legos. I think they're a great prototyping tool, and for sure it can help you just create different mechanisms. To be honest, like, just waking up and working with robots, I think it's just phenomenal. Like, sometimes we have hard time believing that we're doing stuff like that. And like you see friends in your lab, Discovery Channel comes here and talk to them. You see friends in your lab, NASA contacts them to find out their research, how can they modify stuff to add to their aircraft. So it's just amazing, like the people that you are surrounded by, the professors, their expertise, world-renowned people. I think, yeah, it does feel like a dream for sure, for sure.